Today we're going to go through lesson 5-6 in your textbook, Inequalities in One Triangle. Our objective in this section is to use inequalities involving angles and sides of triangles. And there's three main things we're going to look at. The exterior angle sum theorem, which we already know, and we're going to apply some inequalities to that theorem and come up with a corollary to that theorem, which is an extension of the theorem. We're going to use inequalities in order to order sides and angles of a triangle. We'll be able to list the sides and angles in order from smallest to largest and vice versa. And then finally, we'll look at Theorem 512, the triangle inequality theorem, which will allow us to look at a couple sides of a triangle and then try and figure out what the possibilities for the third side are. So let's look at the solve it activity, which starts lesson 5-6, which kind of gets us prepared for what we're going to do in this lesson. It says for a neighborhood improvement project, you're going to build a new sandbox at the playground. You have two boards that will make up two sides of the sandbox. One of them's 5 foot, the other's 8 foot. And boards come in the lengths shown at the right. The question is, which boards can you use for the third side of the sandbox? So over on the right, we have boards of size 15, 12, 8, 5, and 2. We're already using the 8 and 5. So we want to know, is that third side, should we use the 15-foot board, the 12-foot board, or the 2-foot board, or does it really matter? So the question is, can we use a 2-foot board? And then to explain, well, let's take a look at what happens if we use the 2-foot board. Do you see an issue with that? The 2-foot board is too short. It's not going to make a triangle if we use the 8-foot board, the 5-foot board, and the 2-foot board. So these two smaller sides, we're going to explore the two smaller sides and see what has to be true as compared to the third side. So does the 15-foot board work? No, it doesn't work as well. So the only board that's left is the 12-foot board. So we could use the 8-foot, the 5-foot, and the 12-foot board to form the triangle because the 2-foot board is too short and the 15-foot board is too long. And that's what we're going to look at in Theorem 512. Let's take a second to quickly review the exterior angle sum theorem of a triangle. We learned a couple chapters ago that the measure of an exterior angle of a triangle, so in this case angle 1, it was equal to the sum of the two remote interior angles, those interior angles that were on the other side of the triangle from the exterior angle. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And so the corollary, the extension that we're going to look at today, basically says this, that the measure of angle 1, because it is 1 plus 2, the measure of angle 1 has to be greater than the measure of angle 2, and the measure of angle 1 has to be greater than the measure of angle 3. If these two added together were equal to angle 1, then angle 1 has to be greater than either of the other two angles. And it's more of a common sense kind of idea, but it is an extension of that triangle angle sum, or the exterior angle sum theorem. So here it is as a key concept from your book. The measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. And so this kind of fits the picture that I had in the notes before. The next thing I want to take a look at is kind of a combination of Theorem 510 and Theorem 511. I'm kind of putting them both together here. And I'm going to try and simplify it a little bit. And it has to do with ordering the sides and angles of a triangle. So let's say we're given this triangle. We'll say angle A is 48 degrees, angle B is 82 degrees, and angle C is 50 degrees. What we want to look at is, what is the longest side of this triangle? And we don't know anything about the sides. All we know are the angle measures. But that's enough for us to at least be able to figure out what the longest side is, the shortest side, and then the side in between. And 510 and 511 put together basically say this, that the longest side of a triangle is always opposite the biggest angle. And the shortest side of a triangle is always opposite the shortest angle. So in this triangle, we know that the biggest angle that we have here is 82 degrees. That's angle B. So that means the longest side of the triangle is opposite angle B. It's on the other side. So in this case, AC is the side that is opposite the biggest angle. Therefore, it is the longest side. So what would the shortest side be? Well, we need to find the smallest angle. And in this problem, the smallest angle of the three is 48 degrees. So the side opposite the smallest angle will be the shortest side. So for our triangle, it would be side BC. So in other words, the bigger the angle on the other side, the longer the side is. And the opposite also holds true if we know the sides and we want an angle, or we want to name the angles in order. So let's say we have triangle ABC here as well. If we were to put the angles in order, let's go from smallest to largest. Well, let's find what is the smallest angle. Well, we need to look at the sides and decide which side is the smallest. And in our triangle, AB is the smallest side. So the angle on the other side of the triangle will be angle C. So angle C is going to be the smallest angle. Let's get the largest angle. Well, that's going to be angle B because 16 is our largest side. So our largest angle will be on the other side. So angle B is going to be our largest angle. And that means angle A has to fall in the middle. And if we order the sides 7, 9, 16, we would see that the angles opposite that fall in the same order. That angle C is opposite the smallest side, angle A is opposite the next smallest side, and angle B is opposite the biggest side.
In this problem, you will use the theorem 511. Which choice shows the sides of triangle TUV in order from shortest to longest? Your choices are A. Segment TV, segment UV, segment UT. B. Segment UT, segment UV, segment TV. C. Segment UV, segment UT, segment TV. Or D. Segment TV, segment UT, segment UV.
And I want to interject here. Make sure you pay attention to the directions because it asks in order from the shortest to the longest. So we're going from small to big. It's easy to miss that. So pay real close attention to the wording in your homework problems.
How do you use the angle measures to order the side lengths? List the angle measures in order from smallest to largest. Then replace the measures of each angle with the length of the side opposite. Remember that the triangle angle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. The degree measure of angle U, 58, plus the degree measure of angle V, 62, plus the degree measure of angle T equals 180. Add 58 plus 62. Subtract 120 from each side of the equation. By the triangle angle sum theorem, the degree measure of angle T equals 60. Substitute the correct angle name for each measure. Use theorem 511 to substitute the opposite side for each angle. Segment TV is opposite angle U. Segment UV is opposite angle T. Segment UT is opposite angle V. By theorem 511, the length of segment TV is less than the length of segment UV, which is less than the length of segment UT. Choice A is correct.
Now, if we go back to our solve it activity that we started the lesson with, remember we had an 8-foot board and a 5-foot board, and we had to decide, should we use the 15-footer, the 12-footer, or the 2-footer to make a triangle to build the sandbox for the playground. And we said that the 2-foot board was going to be too short, the 15-foot board was too long, because neither of these options did we end up with a triangle, because we have this gap here and this gap here. We never really ended up with a triangle. That the 12-foot board was best. So we're going to use this kind of an example to move into theorem 512. Theorem 512, the triangle inequality theorem states, the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. The sum of the lengths of any two sides has to be greater, there's an important word, greater than the length of the third side. Let's put this to application. So the question is, can a triangle have sides with the given lengths? And we're given 3 foot, 7 foot, and 8 foot. Theorem 512 says the sum of the lengths of any two sides has to be greater than the third. So let's check them all. Is 3 plus 7 greater than 8? That will be the first thing we're going to check. So I use the first two sides. Let's use 7 and 8. Is 7 plus 8 greater than 3? And then finally, is 3 plus 8 greater than 7? If all of those are yes, then we will have a triangle. If one of those happens to be no, we cannot make a triangle out of those lengths. So 3 plus 7 is 10. Is 10 greater than 8? Yes. 7 plus 8 is 15. Is 15 greater than 3? Yes. And 3 plus 8 is 11. Is 11 greater than 7? Yes. So can we have a triangle with these lengths? The answer is yes, because theorem 512 says that these three sides will form a triangle. If we try it again, can a triangle have sides with the given lengths? We're going to have to add two sides together, and they have to be greater than the third side. Now this one's kind of a tricky problem, which is why I worked this as an example. Because the first two lengths are 5 and 10. So is 5 plus 10 greater than 15 is the question. Now why do you think this trips people up? Well, because 5 plus 10 is equal to 15. So is 15 greater than 15? And the answer is no, it is not greater than itself. 15 is equal to 15, but not greater than. So with this kind of a problem, sometimes it gives people some problems, but no, a triangle could not have sides 5, 10, and 15. Imagine if we had boards that had a board of length 15, a board of length 10, make it a little bit longer, and a board of length 5, they are not going to form a triangle. If we continue to kind of rotated this 10 and this 5, what's going to happen? They're not going to make a triangle, because then this would be 10, this would be 15, and we kind of end up with a straight line. We would not end up with a triangle. The last thing we wanted to go through in this section was finding the possible sides or side lengths for the third side of a triangle if we're given two of the sides. So in this problem, we have a triangle that has side lengths of 4 feet and 9 feet. What are the possible lengths for the third side? Now, if you look in your book or you look at an example, if you go through your Math Excel homework and use the View an Example button, they're going to go through a different way of doing this. I want to give you a shortcut for this. And the shortcut is simply this, that if the two sides have lengths of 4 and 9, then the third side is going to have to be, so let's do it this way. Let's go, the third side has to be greater than 9 minus 4, and the third side has to be less than 9 plus 4. And I put that the wrong direction. Let me erase that. The third side has to be less than 9 plus 4. In other words, the third side is going to be between two values. So the third side has to be greater than 5, and it has to be less than 13. So in other words, that third side has to fall somewhere between 5 and 13. And if you want to see the way that your book explains it, you can go to your Pearson Realize site and look at one of the example problems. I think it's problem number 5. You can go through the module, kind of like the ones I've inserted in this video. But it does it a little differently. I kind of like to do it this way, kind of a shortcut. Let's do another problem here. And let's say we have a triangle with side lengths of, let's go 10 and 21. That third side that we don't know is going to have to be between 21 minus 10 and 21 plus 10. So that third side is going to have to fall between 11 and 31. Any other values that don't fall between 11 and 31 will not make a triangle. So here's the question: can the third side be exactly 11? And the answer is no, because if that third side is 11, then 11 is not greater than 11. It's equal. But again, that always seems to confuse people, and I wanted to make that point. Okay, that's lesson 5-6, inequalities in one triangle. And we use those inequalities in one triangle to try and find missing sides, missing angles, to order the angles and to order the sides using inequalities.